Hello students, I am Laxman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in this hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. Students, I hope you have seen the previous lectures. Now today also we'll continue with some basic concept of chemistry. Today we shall be discussing limiting reagent and the reactions in solution. Let us quickly recap what we had done in the previous day. We had discussed about the stoichiometric coefficient and the calculation involved in the stoichiometric coefficient. The topic that we discussed today also involves these concepts. So let us have a quick recap of what we had done the previous day. Today we'll do stoichiometry and stoichiometric calculations. The word stoichiometry comes from two Greek words, stoichion meaning element and metron means measure. In stoichiometry, we deal with the calculations involving the reactant and the product. Basically, it gives the quantitative relationship between the reactants and product. These relations can be in various terms. There can be mass to mass relationship, there can be mass to volume relationship, or there may be some other relationship between the reactant and the product. Before we understand how to calculate the amount of reactant or those of the product required, we need to understand that a balanced chemical equation is must for the stoichiometric calculations. So we need to understand how to balance the equation first, then we will be able to solve the questions based on the stoichiometry. For the stoichiometric calculations, in fact, whatever the information we require, we get it from the balanced chemical equation. Here we have taken example of combustion of methane, and the reaction is written as methane burns in air or oxygen to give carbon dioxide and water vapor. This reaction we are already aware. We have already done this type of reaction in grade 10th also. Okay, so we are taking example of that only. So methane is CH4. It burns in air or oxygen O2 to give CO2 plus H2O. Now we have balanced the equation also. We have put 2 in front of O2 and 2 in front of H2 so that the entire equation become balanced. The atoms on the left hand side and the atoms on the right hand side, they are equal in number. Okay, so this is your balanced equation. Now here, these numbers which are in front of any of these chemical substances, they represent the numerical coefficient, and here we call it as the stoichiometric coefficient. Okay, so we have got 2 in front of O2. Similarly, in H2O also we have got 2 in front of it. Okay, these are the coefficient of stoichiometric coefficient of O2 and H2O. And in front of CH4 and CO2, the stoichiometric coefficient is 1. Okay. Now, what do these stoichiometric coefficient indicate? Yes, we have got slight idea of this one. We already know this. They not only represent the molecules, they also represent the number of moles taking part in the reaction. Now, how to interpret this one? When 1 mole of methane burns in 2 mole of oxygen, we get 1 mole of carbon dioxide and 2 moles of water vapor. This is what we interpret from the balanced equation. Okay. Now, these can be converted into any type of quantities that we have to find out. For example, we can draw out a mass and mass relationship between these different quantities. We can find out the mass and volume relationship between these quantities, or we may find out the volume and volume relationship between these two quantities. Okay, these two quantities can be any one of these. It can be reactant only, it can be reactant and product, or it can be your only product also. Let us try to understand the limiting region first. At time when the reaction takes place, the reactants are not present in amount as required by the balanced chemical equation. In such case, the reactant which is lesser in amount will limit the amount of product which is formed in the reaction. So basically, the reactant which is lesser in amount, it will decide how much of the product will be formed in the reaction, and it gets completely consumed in the reaction. So it is called the limiting reagent. The reactant which is lesser in amount, that is called the limiting reagent, because it will limit the amount of product which is formed in the reaction. Let us try to understand this taking some example. Let us suppose uh, a factory manufactures car. Okay, in 1 hour the number of bodies which are manufactured is, let's say, 100. Okay, and it manufactures tires for, let's say, 100 cars only. However, in 1 hour only 80 engines are manufactured. So in 1 hour, how many cars will be produced in the factory? Yes, the answer is obvious. It will be around 80 cars which will be produced in the factory. It is because the finished product will depend upon the substance which is least in amount. Here, the engines that can be manufactured is only 80, whereas we can have the tires for 100 cars, we can have the bodies for 100 cars, but the completely manufactured car in 1 hour will be only 80, because we have got engines for only 80 cars. No matter what is the amount of body produced, what is the amount of tire produced, okay, the production will depend only upon the engines here in this case, because that is being produced in lesser amount. So this, in this case, the engine is the limiting reagent. Similarly, in a chemical reaction, the substance or the reactant which is least in amount is called the limiting reagent. Now let us try to use the concept of limiting reagent in solving a numerical. Here we have in the question 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Calculate the amount of ammonia formed and identify the limiting reagent in the production of ammonia. So we have been given 50 kg of nitrogen and 10 kg of hydrogen, which are mixed to form ammonia. We have to calculate the amount of ammonia which is produced, and also we have to identify the limiting reagent. Before we find the amount of ammonia formed, we need the limiting reagent, so we will calculate the limiting reagent first. The balanced equation is N2 plus 3S2 gives ammonia. Okay, so when we balance it, we have got 1 mole of nitrogen reacting with 3 mole of hydrogen to give 2 mole of ammonia gas. This is the balanced equation, and when we are solving these type of numericals, we need the balanced equation, which is must. Okay, now since the masses here is given in kg, we'll convert the mole into kg. Okay, first of all we'll require gram. Since 1 mole equal to gram molar mass, so 1 mole of nitrogen means 28 gram, 3 mole of hydrogen means 3 into 2 equal to 6 gram, that is the gram molar mass, into 3. Okay, it will give the 6 gram of hydrogen. Gram molar mass of ammonia is 17, and since we have got 2 mole, therefore 2 into 17 equal to 34 gram. That is the masses of the different substances according to balanced equation, which is required for the chemical reaction to take place, and which will give the required amount of, let's say, ammonia here. Since here nitrogen and hydrogens are given, okay, the amount of these two are given, so we have to find out the limiting reagent out of these two. Let us try to find it out. Since 28 gram reacts with 6 gram of hydrogen, therefore 1 gram of nitrogen reacts with 6 upon 28 gram of hydrogen. Therefore 50 into 1000 gram, that is basically kg, 50 kg has been converted into gram. Therefore 50 into 1000 gram will react with 6 upon 28 into 50 into 1000. That works out to 10,714.2857 gram, and when converted into kg, it is equal to 10.71 kg. But how much of hydrogen do we have here? We have only 10 kg of hydrogen, whereas for 50 kg of nitrogen, the amount of hydrogen required was 10.71 kg. So do we have the required amount of hydrogen? No. We have less amount of hydrogen present in our reaction. So hydrogen is the limiting reagent. Next part of the question we will solve, that is how much of ammonia will be produced. So what will decide the amount of ammonia produced? It will be hydrogen, which is the limiting reagent. It will decide how much of ammonia is produced. So we will have to correlate hydrogen and ammonia. Now that we have found out the limiting reagent, and we know that the amount of ammonia produced will depend upon the amount of hydrogen. So correlating these two, we have from the balanced equation 3 mole of hydrogen gives 2 mole of ammonia. That means 3 into 2 gram, that is equal to 6 gram of hydrogen gives 2 into 17, that is 34 gram of ammonia. Therefore 1 gram will give 34 upon 6 gram, and since we have 10 kg, converting that into gram, we have 10 into 1000 gram will give 34 upon 6 into 10 into 1000, multiplying by 10 into 1000 on both the side, we get the answer equals to 56666 56,666.67 gram, and converting it into kg, we get 56.66 kg of ammonia. So if we have 10 kg of hydrogen, then 56.66 kg of ammonia will be produced. And here it was hydrogen, which is the limiting reagent, which will decide the amount of ammonia produced. It is always the limiting reagent which decide how much of the product will be formed. Let us try to solve one more question based on limiting reagent. We have here 3 gram of hydrogen reacts with 29 gram of oxygen to yield H2O. Find the limiting reagent, also the amount of H2O formed and the unreacted amount of the reactant. Okay, so the balance equation is 2 hydrogen molecule reacts with O2 to give 2 molecule of H2O, or we may say that 2 moles of hydrogen reacts with 1 mole of oxygen to give 2 moles of water vapor. Now, according to question, the given mole of H2 that we have is 3 upon 2, 3 gram is given, divided by 2, that is the molar mass. So the mole of hydrogen comes out to be equal to 1.5 moles. Similarly, the mass of oxygen is given, that's 29 gram. If we divide it by the molar mass, that is 32, we get the number of moles of oxygen given, and it is equal to 0.9062 moles. Now, according to the balanced equation that we have here, 2 moles of hydrogen reacts with oxygen. How many moles? Yes, it is 1 mole. 2 mole of hydrogen reacts with 1 mole of oxygen. So 1.5 moles of hydrogen will react with 1 upon 2 into 1.5 moles of O2, that works out to 0.75 mole of O2. That means 1.5 moles of hydrogen will require 0.75 moles of oxygen to react with. But the available mole of oxygen is 0.9062, which is greater than the required amount of 0.75 moles of O2. Thus, we have oxygen in excess. Therefore, hydrogen will be the limiting reagent in this case, and hence the product formation will depend upon the amount of hydrogen, which will limit the formation of water molecule here. So in next part we will be solving that. In the second part of the numerical, we had to find out the amount of water molecule formed and also the excess reagent. Now we will make use of the same balance equation. 2H2 plus O2 gives 2H2O. That means 2 mole. We have to find out relationship between hydrogen, which was the limiting reagent, and the water molecule that is formed here. And they are related as 2 mole of hydrogen reacts to give 2 moles of water vapor. Therefore, the relation is 1:1. So 1.5 moles of H2 will give water molecule equals to 1.5 moles of H2O. And the mass of 1.5 mole of H2O is 1.5 will be multiplied to the molar mass. So 1.5 into 18 equal to 27 gram. So in gram, the water molecule formed is 27 gram. Also, we have 2 moles of hydrogen reacts with oxygen equal to 0.75 mole. But the amount of oxygen that we have been given is 0.9062. Therefore, subtracting 0.75 from 0.962, we get 0.1562 as the unreacted moles of oxygen. This is the excess amount of oxygen that we have. We were given 0.9062 and the consumption of oxygen was only 0.75. So this one remains 0.1562 moles remain unreacted. Let us discuss the reactions in solution. Most of the reactions that we carry out in labs are in the form of solution. Therefore, it becomes important to understand how the amount of substance is expressed when it is present in the form of solution. The concentration of solution can be expressed in various ways. Some of these are in term of mass percent or weight percent. Then it can be in term of mole fraction. Then it can be in form of molarity or molality. There's difference between molarity and molality. Before we start with the methods of expressing concentration of solution, we need to understand a few terms related to it. The first one is your solution. Solution is a homogeneous mixture of two or more chemically non-reacting substances. Then the solution may be binary, ternary, quaternary and so on, but most of the solution that we will be dealing here will be only binary solution. That is the solution consisting of two components. One of the component is called solute and it is generally present in smaller amount, and another component is solvent. It is a component present in larger amount. Although the technical definition is not exactly this one, the exact definitions we will be discussing in the solution chapter. Now let us discuss the methods of expressing the concentration of solutions. The first one is your mass percent. Mass percent is the amount of solute in grams present in 100 gram of solution. So the formula is mass percent of solute equal to mass of solute upon mass of solution into 100. Since mass of solution is the sum of mass of solute and the solvent, therefore it can also express in term of mass of solute upon mass of solute plus mass of solvent into 100. At time the volume and density is given, then the same mass percent of solute can be expressed as mass of solute upon volume of solution into density of solution into 100, since V into D equal to mass. Okay, so this is the mass percentage of solute when the mass of solution is given, or when the mass of solute and the mass of solvent is given, or when the volume of solution and the density of solution is given. Then we can use these methods, these formula to solve the mass percentage of solute. The concentration can also expressed in term of percent by volume, and this is equal to volume of solute upon volume of solution into 1000. Then another way of expressing the concentration is percent mass by volume, and this is equal to mass of solute upon volume of solution into 100. You will have to remember these formula to solve numericals. We will take up examples of few of these one by one. Let us take one example here. A solution is prepared by adding 2 gram of a substance A to 18 gram of water. Calculate the mass percent of solute. In the question we have mass of solute equals to 2 gram, mass of solvent, which is larger in amount, is equal to 18 gram. According to the formula, mass percent of solute equals to mass of solute upon mass of solute plus mass of solvent. Here mass of solution is not given, but the solute and solvent are given separately. So sum of these two will be equal to the mass of solution into 100. Okay. So mass percent of solute equal to mass of solute upon mass of solute plus mass of solvent into 100. We put the value of all these quantities mass of solute equal to 2 gram upon mass of solute 2 gram plus mass of solvent 18 gram into 100. That works out to 10%. So the mass percent of the substance A, which is 2 gram in 18 gram of water, is 10%. Let us try to solve question based on volume. A solution is prepared by adding 10 ml ethanol with 120 ml of methanol. Calculate the volume percent of ethanol. Since volume of ethanol is 10 ml and volume of methanol is 120 ml, we can consider ethanol as solute and methanol as solvent. Therefore, volume percentage of ethanol equals to volume of ethanol upon total volume, that is volume of solution. So that will be equal to volume of ethanol plus volume of methanol, and the volume percentage is equal to volume of ethanol upon volume of ethanol plus volume of methanol into 100. Putting the value, we have volume of ethanol equal to 10. We have put that value in numerator as well as denominator, plus 120 ml is the volume of methanol that we have added in the denominator, and all this multiplied to 100. The volume percentage comes out to be equal to 7.7% V by V. Today we discussed limiting reagent and solved few numerical based on limiting reagent. Also, we expressed the concentration in various way, and we tried to solve numerical based on mass percentage and volume percentage. We will be doing the same in our next lesson also. We will be expressing the concentration terms in various other way. Till then, you can try some numerical based on these concepts which we had discussed today. So till tomorrow, till next we meet, have a nice day.